Welcome to solverfy.
Okay, so in this problem, we are given with a reaction of the conversion of ammonia to NO, and in this reaction, we are given that 2 gram of ammonia reacts with um, 2.5 gram of O2, and we have to find out what is the limiting reactant. So, to find out the limiting reactant, first you have to know the number of moles for each reactant. So since you're given 2 gram ammonia, we have to find out what is the number of mole for 2 gram of ammonia. So number of moles of ammonia is since the mass is 2 gram, we write 2 gram over the molar mass of ammonia, which is 17.024 gram per mole, give us 0.117 mole. So this is the number of mole of ammonia. Similarly, the number of mole of O2 will be, we are given 2.5 gram O2. So the number of mole of O2 will be 2.5 over the molar mass of O2, which is 32 gram per mole. Since we have oxygen molecule here, and for one oxygen atom we have 16 grams, so for O2 we'll have 32 gram, and it will give us 0.078 mole of O2. So this is the number of mole of NH3 or ammonia, and this is the number of mole of oxygen. Now we have to find out which one is the limiting reactant, and as we know that the limiting reactant is the reactant which will be completely consumed. So since from the balanced equation you can see that for 4 mole of ammonia we need 5 mole of oxygen. So that means we need more oxygen than ammonia in the balanced reaction. That means we'll find out how many mole of oxygen we need to react with 0.117 mole of ammonia. So 4 mole of ammonia react with 5 mole of oxygen. 4 mole ammonia will react with 5 mole oxygen. That means 0.117 mole ammonia will react with 5 by 4 times 0.117 mole, which is equal to 0.146 mole O2. So for 0.117 mole ammonia, we need 0.146 mole O2. But here we have only 0.078 mole O2. That means we have less amount of O2 than we require. And as we know that if we have less amount of a reactant than we require, that means that is our limiting reactant, and that reactant will be completely consumed in the reaction. That means in this reaction our limiting reactant is O2. Now in the second part we have to find out how many grams of NO and H2O will form in this condition. So to find out the number or the amount of products, what we have to do, we have to first find out the number of moles of the products which will be produced, and from there we can find out the mass of the products. And while finding out the moles of product, we have to consider the limiting reactant. That means we will do our calculations based on our limiting reactants. That's why From here you can see 5 mole of O2 can produce 4 mole of NO. That means we have to find out how many mole of NO will be produced from 0.078 mole of O2. So 5 mole O2 will produce 4 mole of NO. That means 0.078 mole O2 will produce 4 over 5 times 0.078 mole, which is equal to 0.0624 mole. So 0.0624 mole NO will be produced. And if we want to find out the mass of NO from here, we just have to simply multiply this number of mole of NO by the molar mass of NO, which is 30 gram per mole. It will give us a value of 1.87 gram. So in the reaction condition, we will have 1.87 gram of NO being produced. Now we'll find out how many gram of H2O will be produced in this condition. So again, from here you can see 5 mole of O2 can produce 6 mole of H2O. We have to find out how many mole of H2 will be produced from 0.078 mole O2. So um, 5 mole O2 will produce 6 mole H2O. That means 0.078 mole O2 will produce 6 over 5 times 0.078 mole, which is equal to 0.094 mole O2. And if you want to find the mass of O2, we just simply multiply this number of moles by the molar mass of O2, H2O, which is 18.016 gram per mole. This will give us a value of 1.69 gram H2O. So 1.69 gram of H2O will be produced in this reaction condition. Now in part C, we have to find out how many grams of the excess reactant will remain. So for that, we have to find out how many grams of the excess reactant, which is ammonia, since O2 is our limiting reactant, that means ammonia is our excess reactant. First, you have to find out how many mole of ammonia will react with this much mole of O2, and the rest of the mole will be our excess. And from there, we can find out the excess mass of reactant remaining. So first, we can write 5 mole O2 react with 4 mole ammonia. That means 0.078 mole O2 will react with 4 over 5 times 0.078 mole, which is equal to 0.0624 mole. So this is the number of mole of ammonia which will react with this much mole of oxygen. And if you want to find out the mass of ammonia which is reacting, we just simply multiply the number of mole of ammonia by the molar mass of ammonia, which is 17.016 gram per mole, and this will give us a value of 1.06 gram. That means 1.06 gram of ammonia will react with the oxygen which is provided. That means the excess amount of ammonia remaining will be, so we are given with 2 gram of ammonia. That means the excess of ammonia remaining will be 2 minus 1.06 gram, which is equal to 0.94 gram. So 0.94 gram is the mass of the excess reactant which will remain after the limiting reactant is completely consumed. Now in the last part we have to find out that our calculations are consistent with the law of conservation of mass. So that means the law of conservation says that the mass before the reaction, or the mass of the reactants reacting, will be equal to the mass of product which is produced. So here we have, so 1.06 gram of NH3 is reacting with the 2.5 gram, with 2.5 gram of oxygen. That means the amount of reactant which are reacting is 2.5 gram O2 plus 1.06 gram NH3, which is equal to 3.56 gram reactant. And we are producing 1.87 gram NO and 1.69 gram H2O, which is equal to, the sum is again 3.56 gram product. That means the mass of reactants reacting is equal to the mass of products which is produced. That means our calculations are consistent with the law of conservation of mass.